Hello friends, let's solve this physics problem. It's on friction. It says we should calculate the acceleration of this system. Now there are two assumptions. The first one is this rope is massless, and the second assumption is that this plane is frictionless, so we wouldn't have to deal with the frictional force. Okay, so this sign is an indication that the system moves in this direction, so it slides in this direction. Okay, let's proceed as follows. I have to resketch it. I have this. Um, This plane is inclined to an angle of 30 degrees. This mass runs this way, 20 kg. Of course, the weight equals mg equals 20 times 10. 10 is acceleration due to gravity, which is 200 Newton. That is the weight acting vertically downwards. Now, you have this kind of pulley system, and this weight is, the mass is 30 kg acting vertically downwards. 30 times 10 is 300 Newton. Of course, the tension, this is the tension in the string, has to act in the opposite direction to be attached with. Okay? Now, this mass now, or this width, 200 Newton, is with respect to this plane, is inclined at an angle. So we resolve it into its components. If you look at it very well, discover that you have, this is normal reaction. Of course, the weight has to react, okay, upon making contact with this plane. So it will act vertically with this, and if we resolve, force is a vector, so it will be this way, so that this component or this component gives us this component. Okay, now this line makes an angle of 90 degrees with this plane, this horizontal plane. What it means is that this angle plus this angle plus this angle is 180, so here should be 60 degrees. This line makes an angle of 90 with this plane, so here will be 30 degrees. Okay, so if we use Pythagoras, of course, this is 90 degrees. We use Pythagoras SOHCAHTOA as the sign. Here gives us mg cos theta. This side gives us mg sine theta. Okay, now you discover that this tension, we resolve into components. We've resolved into components. So with respect to this force, I would have this width, I would have normal reaction R, opposite it is mg cos theta. This other side is the tension. This other side is mg sin theta, mg sin theta. Okay, so this, no, don't forget that the motion is in this direction, meaning tension is greater than mg sin theta. This is the reason it moves in this direction, but it doesn't move either way. It doesn't move up or down. Therefore, R equals mg cos theta. But we're not using, because we're not required to calculate the normal reaction, but the acceleration. So tension, the net force will be tension minus mg sin theta equals the linear acceleration times mass. Okay, so this is weight, mg is weight, is 200 Newton. So we have T minus 200 Newton, 200 sine 30 equals 20A. We call it equation 1. Okay, now with respect to this mass, we just have two forces, tension up and the weight downwards. Of course, we know acceleration is in this direction. So we're having, let me do it that way. We resolve this one. We have up is tension, down is 300 Newton, and the acceleration is in this direction. So since it goes in this direction, it means that 300 Newton is more than tension. So we have the net force will be 300 minus tension equals MA, where M is 30 kg. So we have 300 minus T equals 30. This is equation 2. So from this 2, T is something as 300 minus 30A. So let's call this equation 3. So we use equation 3 in 2. Wherever we see tension, we put 300 minus A, okay? Now here we have T, which is 300 minus A, minus 30A, minus 200. Sin 30 is 0.5, is a popular term, equals 20A. So I have 300 minus 200 times 0.5 is 100, equals 30 crosses, it becomes 50A, okay? Let me wipe here, let's see. So we now have 50 equals 200. Becomes 200 over 50. That is 4 meters per second square. So the answer is 4 meters per second square. I hope this helps someone. Thank you very much.